Okay, so 11.3, the substitution rule, aka reverse chain. So just kind of shows you here, original y is square root x squared plus 1. So if we were doing the derivative of that, that'd walk us all the way down to this guy here, which would be derivative of the inside's 2x. We drop the 1/2 in front, negative 1/2 on top, puts it on bottom. And so this would be your derivative here, be your y prime. So then conversely, they're just saying we need to figure out now how to get here to there. Like, how do we get back to that? How do we get back to that before the chain rule type thing? Okay. So in general, we're going to kind of figure out that essentially we're going to use substitution to help us with that. So what this stands for is the antiderivative of g of x times g prime of x is the same thing as the antiderivative of g of x. A lot of this is just kind of setting you up for the actual rule here. So I'll just kind of skip through this part and get to this, which is a little bit easier to explain. So what we are going to do here is the substitution rule for indefinite integrals is we are going to go f of g of x, g prime, x dx, or f of u. So what that means is that we are going to get something that looked like it had some sort of chain rule happen. So if I just got like, if it said we want to do the integral of that, we knew that before that had a chain rule, right? Because there was something on the inside. So what we're going to do is, if you're wondering what are they talking about, we're calling this our g of x. That's the thing we're going to sub. So what you'll do is you'll come over here, and I'm going to do this in a second. You'll identify what is u. So u in this case is x squared plus 2x. That's the thing I'm subbing out for right now. You'll see, and then you're going to say, what is your du? So what's the derivative of that? 2x plus 2. And then we call that dx. I'll explain that in a second. So that's how we're going to set up our substitution, u du. Okay? So again, so we're letting u be the g of x, the thing that's on the inside. The reason we do that is because then we're going to go ahead and we're going to differentiate, or not differentiate, integrate u to the 5th du. Okay? We just would do, I'm just going off this random example here. Sorry. u6 to the 1/6 is what it would be, right? Plus c. And now we insert back the u. Okay, we'll talk about the dx and stuff, but that's essentially the idea of substitution. Okay, there's going to be more. Okay, we're going to talk about dx as well. Okay, so just give me a little bit of time here. All I was trying to show you there is what it's going to look like. We're trying to make this u so we can substitute it into pieces to undo a chain rule. Okay, we're going to do a quick example here, and you'll kind of see what I'm talking about. Okay, so let's look at this one. So we want to find the integral of x squared minus 5 to the 8, 2x dx. So first off, what is our u going to be? Our u in this case is going to be x squared minus 5. Du is 2x dx. Now this is important, so pay attention to this part, and we'll go over stuff of this that's a little bit harder in a little bit. Notice that my du is already here. Du is 2x dx, right? So what that means is that I'm good. This is an easy one. That means I'm going to simply go, okay, here, u8 du. We put u in for this, du for that, because that's what it's equivalent to. This one lined up easily. They won't do that all the time. Yep. Say that again. Because it's with respect to x. So we took the derivative. So we took the derivative of 2x minus 5. And so if we were doing it, okay, if we were going this way, so we're taking the derivative. If we're going backwards, when you have dx, it goes away because it's undoing the derivative. So we put that in place for the derivative of du with respect to x. So 2x minus 5, I'm trying to figure out here, hold on. I know it's because we're using u's. Yeah, it's because we're using u's, that's why. The derivative with respect to it's du, so it's just, this is x prime. 2x x prime, that's why. Why is it 2x? How do I know it's du? Because my u, I took the derivative of u. So u prime, if I take derivative with respect to u, that's du, right? So this is with respect to u, that'd be 2x dx. Because that's, remember, it's the x, but we're doing respect to u. So this ends up being x prime. So it's essentially doing a form of implicit, because we're doing it for u. We'll keep doing it. I see your point, but I know what I'm saying is, that's what I mean to say. So let's just try this again. So this is what I'm establishing as my g of x, which we're calling u. So this right here is my g of x, if you will. It's that extra piece that's kind of surrounded by an exponent that we would have to reverse chain. So then we want du, okay, because we want to get back to this form here. F of u du. So to do that here, derivative of u is du. Derivative of u with respect to u is 2x x prime. That is right here, which we can slide in as du now. So now we have everything in terms of u, which is what we want. Because now we're going to integrate with respect to u. So u is nice because now that's just going to be 1/9 u to the 9th plus c. What's that? Remember, when we integrate, we're going backwards, right? So 8 goes to 9. The 9 would have to cancel the 1/9. And now we insert the x squared minus 5 back in. C is always when you don't have limits of integration. When you don't have limits here, we will have some later. You have to do plus c because it stands for a constant, because derivative of a constant is 0, so we have no way of knowing what that's going to be. So when you integrate a derivative, it's 1. That's du. When I integrate that, essentially it goes away. So we like du's and dx's when we're doing integration. Okay, because du stands for derivative, we're doing the antiderivative. So it's just like they cancel each other. Okay? Yep. Okay, so guys, this stands for derivative. If I take the antiderivative of a derivative, it's 1. So du, the antiderivative of du would just be 1. I'm doing the antiderivative, so antiderivatives cancel derivatives. dx and du mean derivatives. Right? So here, let's just do this. Forget that for a second. Let's take the derivative of this. Drop the 9. Okay, that's gone. Derivative of the inside. Be with respect to, because we're still with u.
No, if it was just like 1/9 times x squared minus 5 to the 9, and you take the derivative of that, how do you know with respect to u?
because, one, we took the derivative, so that's the dx. So that's just signifying that we took the derivative. Now this here, I see like this dx is what's hanging us up. That right there is because, I think it's honestly because we haven't established kind of our integration, like what we're doing, what we're integrating in terms of a variable. So let's see, why does the dx stay? That's a good question. I know this is right, but why does it stay? Right. Yes, but this one we just did is the easier one because the du was already laid there for us. It's not always going to happen that way. So let me repeat the first part first. So with g of x here, that's the inside. That's g prime of it, dx. So by definition is where the dx came from the earlier comment, just so I get that on the video here. So then to what you're saying, Emily, see this right here? They laid that out nicely for us because when I take the derivative of this, I got that, which was already there. That's not always going to happen. This could be like 5 x dx, and then we have a little bit of work to do, and I'll show you how to do that in another problem. So this one's an easier one in the sense that the du already matched up. Yep.
So why did you add a c and then make no c?
Well, here, because, yeah, there still would be technically a c here.
Okay.
So actually, no. I took the derivative of this. So I was taking the derivative of this. If that's a constant, derivative of a constant is 0. So I was just showing you guys the derivative.
Oh, gotcha.
If I do the derivative of a constant, that's 0. So that's just not there. Okay, good questions. Anything else? Hopefully, I was hoping to be able to make this seem easier, but I think we're having a lot of questions, which might think it's harder. That's all right. All right, can we look at 2? Okay, all right, so 2. Okay, so a little bit tougher. All right. So let's just go question by question. What do we want u to be? What's the part that's affected by change? Right, 1 minus x cubed. Okay, so 1 minus x cubed is my u. Okay, what is my du? What's that? Negative 3x squared. So here's the tricky part. What's that? Yeah, sorry, thank you. So here's the tricky part. Is there an x squared in the problem? We're good. Is there a dx in the problem? We're good. What is there not? So how would you balance a negative 3 so that essentially it would cancel? What's that? Not that simple. Think about multiplication cancel.
A negative 1/3?
Correct. A negative 1/3. Because negative times a negative is a positive, so that's how they would essentially cancel each other out. It's kind of like, this is probably a weird comparison, but you guys remember completing the square? When you had to pull that number out, you know, multiply it by it to even things out. To even this out, I need a negative 1/3, because that's what I'm missing. Okay, Dana, go ahead. You have a question now? Got it? Any questions on that? Okay, so now this is what it's going to look like. You guys, everybody understand? And how you can figure that out, okay, is you can figure it out by, okay, I have x dx. What am I missing? So like this right here is right there. I'm missing this, so I have to balance that. That's where the negative 1/3 comes from. So I'm going to go ahead and write this. I'm going to write this as negative 1/3 du over like that. So
Y? Is that like a root y on the bottom or a 4?
that's a u.
Okay.
A u. Okay, so that's du on the top.
Yeah, that one's good.
We'll just try to make everything a little consistent here. Okay? All right, so this is where you can do a couple things to your advantage here. That's why we talked about this last class. See this right here? We can say, I don't want to deal with that right now, and we can put them out here. Okay? So we can just say negative 1/3 integration. I can go u to the negative 1/2 du now. And that's a little bit easier, right? We don't have to throw out the fraction because it's a constant. We can just pull it out for a second. Now we're ready to take the antiderivative. Okay, all I did was, that's out, this came up.
Okay, we're good. That makes sense now.
That's all right. So we're going to, remember, when you're doing the antiderivative, you're going to add one of the exponents. So this is going to be u to the 1/2. There was nothing here before, so it has to be a 2, right? Okay, that du, gone, because the antiderivative. Okay, we'll put this here for a second. Like that. What's that? Yep, and then you'd be done after you put the u back in. So that's what we have. We have negative 2/3 1 minus x cubed to the 1/2 plus c. Yeah. Yeah.
Is that it? Now we don't have to do anything else to that?
Nope, that's it. That's the antiderivative. Or that's the integration, sorry. Okay, let's try another one here. So we're skipping, if you're following the book, we're skipping 3 because 3 has ln's and logs in it. So we'll go to the trig one here. Okay, so what do we want our u to be here? 4x. Yeah. Deep breaths. Okay. So we understand it's going to be like this. I have a dx, but I don't have a 4. What's that mean? We need 1/4, correct. Another way of thinking about this is we are essentially, in this case, we're trying to replace dx, right? What if I divided 4 over? That's 1/4 du equals dx. Let me say that again. So everybody's comfortable, I hope, that the derivative of u is 4, and we put the dx here. We just have dx here, so you can be like, well, if I solve for dx, I would get 1/4 du is dx, which is also why that's there. Because that's a derivative of u, right? Does that make sense? Yeah. Remember, I mean, if you really want to, guys, I mean, if the d's are really messing you up, maybe you guys need to be writing u prime. 4x prime. If you want to use your primes, you can. Essentially what it is. Okay, the book's going to say du, dx the whole time, though. So, okay, so we're now here. Again, I could pull the 1/4 out in front, just not deal with it for right now. We're doing the antiderivative of sine. Okay, the antiderivative of sine is negative cosine. And then du's gone. So plus c. That's an awful u again. I know, man. I just can't get it right. Okay? And that's the answer. You have to plug u back in, but it's negative 1/4. That negative just distributes cosine 4x plus c. Yep. Because we didn't have a 4 here. This is u. I just have dx. So when I do the du, I have 4 dx. I need a 4, so I have to balance it with a 1/4. Is that what you're asking? No, because we keep du as du. It's a really good question. You're saying what the 4th and 1/4 cancel? But we don't write those. We leave du as du. That's the purpose of the 1/4 being there. We don't du, we don't ever write, because we're taking the antiderivative. This just goes away to 1. So we don't want to write this as that ever. Does that make sense? Yeah. That's why we have to kick the 1/4 out. Yep. Very good question. You guys are doing great. Anything else? Okay. All right. Why don't you guys try this one? See what you can do for this one. I'll let you try it. A couple minutes. I'll take attendance. Okay. So we all understand that u is here, right? U equals 2 plus sine x. Okay. Du is cos x dx. Aha. Perfect. Thank you. Nice and easy for us. It's right there. So all I have to do now is I go, okay, u to the 10th. I don't know why I put brackets there, but oh well. Du. How am I used, Chris? All right?
Yeah, they're good.
Getting better?
Yeah,
Getting better with age? Okay, so then u to the 11th. Okay, plus c. 1 over 11. That's your answer. Okay, any questions? All right, so we have one more to do.
Sorry, I'm stupid.
Okay, so with this one, this is what changes when you're doing substitution rule for definite integrals. Remember, definite means we're looking at a chunk of space. So we're actually finding the area under the curve more. We're looking at from 0 to 5 or whatever. The key thing here is from A to B, you have to make sure, see where G of A, G of B, so that U that you pick is what we change our limits to. So let me say that again. If you're using substitution, you cannot maintain the same limits of integration because you have changed essentially to U. You're changing up to U's. So you have to change your integration in terms of U. Can I do that, or do you want further explanation? Just do the problem? Okay, so here's the problem. Sine pi t dt from 0 to 1. Okay, you guys, why don't you guys do the integral, but I'll help you with the changing the integration. All right, so sounds like we're all here. So then we're here. Okay. So that means that if we'll take care of the integration in a second. That means that we have sine u, and then what do I need? I need a 1 over pi. Good. Because look, this has been replaced. All I have is a dt, but I need a pi dt, so we had to balance it with the 1 over pi again. We're not doing it from 0 to 1, no. Because we switched to u's, so we have to do our change these in terms of u.
Well, like, b of 0, b of 1, which would be like,
Into the u?
yeah.
Yes. Okay, so Janae was saying it right. We get it from here. We have to change this to there to there. So what I'm saying is you put that in for t, because this is what was for t. So if I put 1 there, it's pi. If I put 0 there, it's 0. So it just changed from 0 to pi instead of 0 to 1. That's what I was just telling that box before. You get it from your u. See right here? G of A, G of B. That's what your u is. Your g of x. Okay. All right, so now we do have to do the integration part. So that's negative cos. So I get 1 over pi times negative cos u. And then we don't have a du anymore. And we're looking at that from pi to 0.
What is that line?
This line is just kind of like after you take the integral, you put this here as this is the spots we're looking to. Because you don't want to leave this here because you did integration. Okay, so it's this minus this, right? Okay, so what's that?
How come you don't multiply?
Multiply.
1 over pi. No, there's a dot there.
It's a dot, yeah.
Oh, okay.
It's negative 1 over pi. Okay. Okay, so now we're thinking about what is cos of pi. Let's see here, the pi over t. Well, if we, let's see here. Because once we go to here and we change our definite integrals to these, we need to stay in u's because we change them to account for the u's. Okay. All right. So what's cos of pi? Negative 1. So that's going to be a negative 1 with a negative 1 plus 1, right? This is negative 1 times that's a plus 1 over pi. Okay, and then we minus, right? Pi to 0. Okay. And then what is cos of 0? 1 times a negative 1 over pi. 1 over pi plus 1 over pi. And that's the answer. Yeah, I can wait. We're done, so we can.
What is that answer?
That is the answer, essentially, from 0 to 1 for this integral. This is the answer. Like yesterday, we got 3.49. Or not, on Friday, we got like 3.49. The area under the curve for that section.
Wait, it's like asking for stuff like that. What? I think I missed that one. What is it asking for?
This is asking, so this is a sine curve. So let's take a second real quick, guys. Let's think about this. You should know this from 30. What does sine pi x look like? So what does pi do when it's next to the x there? It affects the what? The horizontal stretch, correct. So is that going to make it steeper or wider? Pi. Right, so it's going to make them closer.
Yeah.
So we have a sine curve. This is just rough. Mine's probably not right. You could probably put it on your calculator if you want. we know that, well, I'm just going to draw this, and this might not be right now, but it's just like this, whatever, let's say. So let's just say here's 1. So we just got like this and this area under the curve, and that's why it was a minus, so it wouldn't let us get a negative. Remember we talked about that? It's going to subtract a negative area, which will give you a positive area.
So what were the questions saying? Find the integral.
Yeah, this one just says solve the definite integral. This is just solving definite integral. So really it's not telling you to do area yet, but we're going to get some pretty cool stuff with some volumes later. But okay, all right, great. Good job, good class.